All right, here's a wrap up of the last two questions from the review sheet. This proof involving the circles and the chords and the arcs is a bit different than most proofs that we've seen. In the picture, of course, there are many triangles, and as it turns out, this is not a type of proof where you prove that two triangles are congruent or even prove that they're similar. Let's take a closer look. So in this question, they want me to prove that side BE and side CE are the same. And I studied the picture in a few different ways, and I found that the quickest way to prove that those are true is to prove that this triangle is an isosceles triangle. And in order to do that, I'm going to prove that those angles in white are actually equal to each other. So I'm going to make a statements and reason column. And fill out what I do know, or the most important things that I do know. So in the beginning it says that AD is parallel to BC. So we know that AD is parallel to BC, and that produces alternate interior angles that are congruent. But it also proves something else. It also proves that arc AB is equal to arc CD. And the reason would be that parallel chords make equal arcs. And then taking a closer look at those arcs, we know that angle B is equal to half of the measure of arc CD, and also angle C is equal to half the measure of arc AB. And that's due to those inscribed angles, which I'll highlight here. So angle C is half as big as AB, and for that same reason, angle B is equal to half of CD. Well, since that is true, and what makes it true would be to explain what that actually is in the picture. The inscribed angles equal half the arc length. And since AB and CD are the same, I could replace AB with CD. And if that's true, if I can replace AB with CD, then angle C is half of CD, and angle B is half of CD. And since that's true, angle B is equal to angle C. So we could just do one substitution to explain it, or more than one if you wanted to substitute it piece by piece. Which brings us to our final conclusion that BE must be the same as CE. If two angles are the same in a triangle, then it's isosceles and two sides are also equal. So the reason right there could be triangles with two equal angles also have two equal sides. Like I said, a very different proof than what we are typically accustomed to. And then the last question, which we ran out of time in class to discuss, I'll show that here with some detail. Angle 1 has got to be worth 50 degrees because it is linear with the 130 degree angle. Together these make 180 degrees. For angle 2 will end up being half as big as DB. Since angle 2 is an inscribed angle, if I find this arc, this angle will be half as much. Well, I do know that arc because of vertical angles. This is 50, and because 50 is a central angle, the arc also has to measure 50, which makes angle 2 half as much, or 25. Question number 3 brings up a fact that we don't talk about all too much, that tangent lines drawn to a circle always make 90 degrees with a radius that's drawn to the tangent line. And it does look like 90 degrees. It actually is 90 degrees. To figure out number 4, it's going to require a little more thought. To find out 4, you're going to have to think of it this way here, with the interior angle being formed by those two chords. And thinking back to the theorem that goes along with this, the angle 4 will be the average of these two arcs that make up that design like that. So needing to find out what these two arcs are, I've got the one at being 50. I need to find the other blue arc. And there is some help there if we notice we've got a semicircle of 180 degrees. With this being 70, this would have to be 110 to finish the 180 degrees. And then averaging 110 and 50 would give you half of 160, which would be 80 degrees for angle 4. And if once we know that angle 4 is 80, we also know angle 5 has to be 100, because those two angles are linear and must add up to 180 degrees. Figuring out angle 6 becomes possible when we take a look at that 100 degrees and notice that we can get 50 degrees as part of that blue arc because of the central angle being 50 degrees there in the picture, which would make the remaining part of the arc 60 degrees. So the arc that's opening here will give us the angle that's inscribed there as being half as much, or 30. And then finally, angle 7 can easily be found because in a triangle there's 180 degrees, and if I've got 30 and 90, then angle 7 would have to be the rest, which would be 60 degrees.